Okay, question number 4. An office worker looks out the window just in time to see a rock moving upward, passing the bottom of the window. The worker looks away for 1.7 seconds. When he looks back, he sees the same rock is now at the top of the window moving downward. The bottom of the window is 9 meters from the ground, and the window is 1.2 meters tall. A. How high did the rock rise? And B. What is the rock's velocity when it strikes the ground? Okay. So let's see here. Let's say this is the window the worker is looking out of. And here is the worker looking out the window. And down here someplace is the ground. And the height to the bottom of the windowsill is 9 meters. So if we let the bottom be 0 meters, then this height right here is 9 meters, and we're told that the window has a height of 1.2 meters, so then this would be 10.2 meters from the ground. And initially, the rock is moving upward, and it's going to go up, come to a stop somewhere above the window, and then come back down, and then it's going to be right here 1.7 seconds later. So the amount of time it takes to go through this motion is 1.7 seconds. So that time is 1.7 seconds. And then when it gets here, it's got some downward velocity. And in each case, it's got a height of 9 meters at the beginning and 10.2 meters at the end. Or you could always call this 0 and that one 1.2 if you want. And through the whole thing, we know that the acceleration is g, which is 10 meters per second squared downward. So we need to decide which direction is plus. So let's let up be plus, so that makes this negative 10. And then this is some initial velocity, which would be positive, and this is some velocity later, which is negative. So, and we know, let's see, what else do we know? I'm not sure. So let's see, let's go back and review. How high did the rock rise? So at some point, we want to know what is this height right here. And we know that up here, the velocity is 0 meters per second because it's the very height of its path. So that may very well come in handy. So what? Let's see here. I'm going to call this one V1 at the top of the window, and I'm going to call this one V2, just that I've got some labels. So we know that just using a final velocity equals an initial velocity plus acceleration times time, that it took 1.7 seconds to go from V0 to V1. So V1 equals V0 plus GT. So we know G, we know T, we don't know either of these, although we know that their plus and minus signs are opposite. What else? Well, to get all the way up here, we know that that would be 0 meters per second, so 0 equals V0 plus G. Now this is a different amount of time. This is, to get all the way up there, it's going to be less than 1.7 seconds. So I'm going to call that times T2, because it's the time to get up to position where it is V2. Whereas this is T1, and T1 is 1.7 seconds. That height above V0 so V2 squared equals V0 squared plus 2G delta Y. And V2 is 0, so we know that 0 squared minus V0 squared divided by 2G is delta Y. And let's see, what else can we use here? We still have two unknowns. We don't know what V0 is. Oh, wait a minute. I haven't used the fact that this distance is 1.2. So I could use V1 squared equals V0 squared plus 2G times delta Y1, where this would be delta Y2, delta Y1. So yeah, use this and this. Since we know delta Y1 is 1.2 meters, and we know T1 is 1.7 seconds, and we know G in both cases, just like we did in the last question, using a system of equations between these two. So let me actually fill in some numbers so that you aren't overly lost as to what we're working with. So this is going to be V1 equal V0 minus 10 times 1.7. And over here, V1 squared is equal to V0 squared plus 2 times negative 10 times 1.2. So replace V1 with V0 minus 17. Equals V0 squared. And this is what? 2 times negative 10 times 1.2. 2 times negative 10 times 1.2 is negative 24. So this becomes V0 squared minus 34V0 plus whatever 17 squared is, 289, equals V0 squared minus 24. So, as happened in the last problem, the V0 squared subtract out. So, we'll have negative 34 V0 equals negative 313, because we subtract 289 over here. So take that and divide it by negative 34, and we get 9.2. So V0 is 9.2 meters per second. So that's how fast it's going when it's going upward at the beginning of the windowsill. Okay, so we can throw that in here. So this is equal to 9.2 meters per second. So, so this makes answering now how high it goes easy, because we know at the top, so we just now plug that number in here. So, now that'll be how high it will be above the windowsill. So we have 0 squared minus 9.2 squared divided by 2 times negative 10 equals the change in position above the windowsill, because that's where we're starting. That's our reference velocity. So 9.2 squared divided by 20, because it's both negatives, is 4.23. So 4.23 meters above the sill. And the sill is 9 meters above the ground, so plus 9, so 13.2. So the height, at its very height, so that's what it asks, right? How high did the rock rise? So it rose 4.23 meters above the sill, which is the same as 13.23 meters above the ground. Okay. What is the rock's velocity when it strikes the ground? Well, this one is really simpler. I'm going to need to remember this, 9.2 meters per second at the windowsill. So, let's redraw what we have to have. Here's our window. Here's the ground. The rock, when it's going upward, is going at 9.2 meters per second. And that's at an initial height, so y0 is 9 meters. We know that it's going to end up down here, so y final is 0 meters. And still, acceleration is negative 10 meters per second squared. And the question is, what will the rock's velocity be when it gets down to the bottom? So this is going to be v0, and we want to know what's v final down here. Oops, v final, and this is a question mark. So the easiest way is to say v final squared equals v initial squared plus 2 times va times delta x, or in this case delta y. So v final, don't know. The initial, 9.2 meters per second, quantity squared, plus 2 times negative 10 times, now, let's write this out to be y final minus y initial. That's what delta y always is. And delta anything, delta smiley, is equal to smiley final minus smiley initial. Plug anything in for smiley. So in this case, it's vertical position. So this is the final position squared. So the initial position is 9, so that's what goes into y0. The final position is 0. So this is 9.2 squared plus 2 times negative 10 times 0 minus 9. So that's 9.2 squared plus 2 times negative 10 times negative 9 equals v final squared. So v final will be the square root of 9.2 squared plus 20 times 9 is 180, I think. Okay, so 180 plus 9.2 squared gives me the square root of 264.64. Take the square root of that answer, and the answer is 16.27. So the final velocity will be 16.27 meters per second, but let's think about this for a second. What direction will it be going? It'll be going downward, so it asks the velocity. So either you have to write in the word downward, or since we've already declared up to be plus, you can always just insert a negative sign, and that will take care of that.